What if the most profound discovery isn't waiting light years away, but hidden just beyond our own planet, in the very backyard of our solar system? For generations, we've stared at the night sky, wondering if we're truly alone. While definitive proof of alien life remains the ultimate cosmic treasure hunt, the evidence accumulating right here in our solar neighborhood suggests the answer might be much closer and far more mind-bending than we ever dared to imagine. Today, we're diving deep into the most tantalizing places within our solar system, exploring where life might be secretly thriving, and why finding it is proving to be such an incredible challenge. The quest for life beyond Earth usually starts with one fundamental ingredient: water. Specifically, liquid water. It's the universal solvent, the medium for chemical reactions, the cradle of life, as we know it. For a long time, if a place didn't have liquid water, it was pretty much written off. But what if we've been looking for life through too narrow a keyhole? What if life can exist in forms so radically different that our Earth-centric view is actually holding us back? Let's start with a familiar face, a neighbor that has captivated humanity for centuries: Mars. For a long time, Mars was seen as a barren, rust-colored desert, a dead world. But our perception has undergone a dramatic makeover. We now have compelling evidence that Mars was once a very different place, potentially teeming with water. Orbital missions have detected hydrated minerals, basically minerals that contain water locked within their structure, scattered across the planet. We've seen undeniable signs of ancient riverbeds, intricate networks carved into the Martian surface, unmistakable fingerprints of flowing water from billions of years ago. There are even vast reserves of subsurface ice, a frozen relic of a wetter past, just waiting to be tapped. All this points to a distant past where Mars had conditions potentially habitable for microbial life. But what about now? Could there be life on Mars today? That's where things get really interesting and really challenging. Scientists have detected plumes of methane in the Martian atmosphere. Now on Earth, a significant amount of methane is produced by biological activity, things like bacteria in swamps or cows digesting their food. So, finding methane on Mars immediately sparked a huge question. Is it a byproduct of Martian microbes? The problem is, methane can also be produced by geological processes, like the interaction of water and rocks deep underground. So, while it's a tantalizing hint, it's not definitive proof. It's like finding a footprint in the mud. It tells you something was there, but not what or when. And that's the constant tug of war in this search, distinguishing between exciting biological possibilities and mundane geological realities. Now let's venture further out, to the gas giant Jupiter and its mesmerizing moon, Europa. Imagine a world completely encased in a shell of ice, smooth and fractured, looking like a giant cracked egg. But beneath that icy crust, scientists believe, lies a vast, deep ocean of liquid water, more water than all of Earth's oceans combined. This ocean is thought to be kept warm by the immense gravitational tug-of-war between Europa and its colossal parent planet, Jupiter. These tidal forces essentially knead Europa's interior, generating enough heat to keep the water liquid. What makes this so exciting is the possibility of hydrothermal vents on Europa's seafloor, similar to the black smokers found in Earth's deep oceans. On Earth, these vents support entire ecosystems thriving without sunlight, fueled by chemical energy. If Europa has these, it could be a perfect haven for microbial life, hidden away from the harsh radiation of space. Even further out, in Saturn's domain, we find another incredible icy world, Enceladus. This small moon is a true marvel. It's famous for its dramatic geysers erupting from the moon's south pole, spewing vast plumes of water vapor and ice particles hundreds of miles into space. The Cassini spacecraft, which orbited Saturn for over a decade, actually flew through these plumes and tasted them. And what it tasted was astounding. Not just water, but salts, silica, and crucially, organic molecules. Organic molecules are the building blocks of life, the chemical ingredients from which DNA and proteins are made. The analysis of these plumes suggests that Enceladus has an ocean, likely warmed by hydrothermal activity, and that it contains complex organic compounds, essentially a cosmic soup with all the necessary ingredients and a heat source. It's a bold claim, but the evidence makes Enceladus one of the most promising places to find life in our solar system. But what if life doesn't need water at all? this is where Saturn's largest moon, Titan, blows our minds. Titan is unlike any other world we know. It has a thick, hazy atmosphere, even denser than Earth's. But instead of rivers and lakes of liquid water, Titan has entire hydrological cycles based on methane and ethane. It rains methane, rivers of methane flow across its surface, and it has vast lakes and seas of liquid methane and ethane. Can life exist in such an alien environment? Scientists are seriously considering the possibility of what's called hydrocarbon-based life that uses liquid methane or ethane as its solvent instead of water. Imagine creatures that breathe hydrogen, eat acetylene, and excrete methane. The conditions are extremely cold, around 180 degrees Celsius, but the complex chemistry happening in Titan's atmosphere, rich with organic molecules, suggests that prebiotic chemistry, the chemistry that leads to life, is certainly possible, if not probable, on Titan. It pushes the boundaries of our imagination, forcing us to consider that life might be far more adaptable and diverse than our water-centric view allows. So, where does that leave us? We've sent robotic missions to Mars, tasted the plumes of Enceladus, and flown through the thick atmosphere of Titan. We've developed incredibly sophisticated analytical techniques to look for biosignatures, chemical fingerprints that might indicate the presence of life. But despite all this groundbreaking work, conclusive, undeniable evidence for life beyond Earth in our solar system remains elusive. We haven't found a smoking gun. However, the journey itself has already revolutionized our understanding. We've gone from imagining life on Mars to finding evidence of ancient rivers and potentially even present-day methane. We've discovered oceans under ice on worlds we once thought were frozen solid. We've begun to consider that life might be so different that our current methods are like trying to catch a fish with a butterfly net. The prospect of finding simple microbial life, tiny, microscopic organisms, beyond Earth is no longer science fiction. It's a very real possibility that drives an intense global scientific endeavor. Every new mission, every new piece of data brings us closer to answering that profound question. Are we alone? The solar system itself seems to be hinting that the answer is a resounding no, and it's doing everything it can to make us work for the discovery. To see what unexpected secrets the universe might be hiding, check out our next video right here.